Testing 1, 2, 3. 1, 2, 3. All right. Oh, that's right. I was making these ends, these extensions, these clips, bits of 20 gauge. Right up the vent. That's pretty good. Okay. Now I need to get clips. So I will be right back with that. Hello, hello. Right. I got that 1K pot, 25 watts in the bag right there. But I'm going to set up this coil real quick.
No.
All right, so this is the end. The end goes in the ground. This is going to be the start. And the start is going to go into the emitter. Power's already plugged into the collector. I hope we don't have a breach there, because they are kind of knocking. But I think that it should be insulated in between each one of those. Oh, no, wait a minute. No, that's right. And I'm even setting it up right and talking about it wrong. So it should be knocking it, and that's what I'm trying to say. It should bump into each other because it's not insulated that way. All right, so now we got trigger coil. Start. Start goes into the base. We're going to have a dual circuit running this little thing. These little coils right here are dope, man. They're like, I didn't even expect that what came out of these things to come out of them. I didn't get it. I was like, what? They're so tiny. But I mean, if I set this up right, the first time you're going to see two things. You're gonna see me do it right the first time, and then you're gonna see how powerful these things are. Like twice is what I've seen. I only did it with one. And it's just 26 and 32 gauge. Hello, hello. I don't need the I don't need the pulse motor to do that. Well, we'll try it in this hole. All right. Oh my God, moment of truth. I know at least one of them should work. They're both connected to the same power supply, so see what's up. It's 8.8 volts. So it's just under a 9-volt battery. I don't know if the second one's on though. Doesn't seem like it is. Right now I'm just testing coils. Earlier today I built the eddy current collector with these two coils. Just kind of laid them on top of this thing, and then I had a rotor spinning underneath it. And I got about 2.5 volts when it got going really fast. As for like having like a plan, I don't have any plan. I just said I want to spin it, and I don't want to have to like turn it, do it by hand. I don't want to have to crank it. I don't want to have to, whip it every time it slows down and stops. So I said, how do I do that? How do I make that happen? How do I get this thing to spin without me spinning it? And a DC brushless DC motor and contact DC motor, both of those came into the discussion a lot. So this is a DC motor, just a regular old, But here, let me try one at a time. I love this little rotor too. It's just a 120-degree rotor, nice and balanced. It's awesome. It gets up to speed so fast. All right, so let's try the new one and see if it's working right. Moment of truth for that one. Looks like it's gonna work. I don't think it was working. I don't think so. No, I don't think it's working. Let's try swapping the base. Now hold on a second. I want to make sure that that's what it is. All right, that doesn't go there. It goes over here in the emitter slot. And that would mirror, except for the light, the other circuit. No. Well, it was worth a shot. All right, so let's make sure we get these in the right holes. Wait, that's so not right. There it goes. Okay, now what does this go to? Oh, yeah, that's probably not good. Doing this on the wing here is, I'm just a little nervous. That's all. This is the one that needs to go in that slot. What would be great is if nothing gets wrecked. It'd be super. Okay, let's give it one more shot. See, and it's not like I have a schematic to look at to build this. I just threw it together knowing what I needed to do to make it work. And I mean, I put a little extra light in there across a resistor. I think I fried the resistor, though. I'm not sure. So this is like 12 volts. It's so quiet. It's awesome. All right, pull this out. I don't know what's up with that. I mean, could swap the base and the emitter for the trigger. Let's try that. All right. Oh man, that's not good. I don't think it's on anyway. So, I wonder why that one works and this one doesn't. Now I'm thinking if I hook up all this on the other side here and then have a separate power supply like this one or this one right here, we might have different results. But I think that's good. I mean, just look at the size of that freaking coil. It's so tiny. And the gauges are really... Thanks, man. I think... Yeah, I think you commented on this before. Yeah, hell yeah, man. I made it turn. You know, it was a... back when I was just playing with the magnet discs, what I did was I had a 10-inch disc, and I put it every 5 degrees. I'd put a magnet, making a big toroid basically. And I would spin that one with my hand, and it would spin for 20 minutes without a bearing. Just levitating on another toroid disc that I made. And it would spin without a bearing for 20 minutes. But I didn't want to spin it. And now that I, got the motor and I know how to work it and set it up and kind of whatever, and this is all good, it doesn't move like the one with no bearing moved, man. It was awesome. And it wasn't flywheel. It was light. It was light as a feather, man. It was like no inertia, except for that what came from my arm. Something's hot. Anyway, that's the homemade stuff, man. That's cool. I really enjoy doing this. Now, we'll take the power and we'll clip it to this. Yeah, it's really cool, especially when you put something like this on top of it. On top of it and enough up high enough so that it doesn't stop it directly or like very quickly. It continues to spin, man. You get those eddy currents. It's an extra 3 or 4 volts. With these 2 coils, anyway. I mean, you could probably set it up to get a whole bunch, but just with a bifilar 26 gauge, 32 gauge in the little bobbin over here. That's all that is, man. It's pretty freaking awesome. It's about 1,000 turns. Maybe a little less. We're going to extend this coil. Right now it's just a 1 millimeter wire, but we're going to make it 1 millimeter in the 20 gauge strand in there. And then the trigger coil is 32. Awesome. So it's like making big adjustments like that is so much easier with the K Energy circuit, man. It is just, it's really easy to use. So it's well worth it if you buy one. I don't know if I needed to buy it, but it's helping me a lot. Man, what the hell? Oh, there we go. Man, that's the second time I said that, though, so that's not good. All right. $12 volts, since that's the output. I know what I want to do. And now that wire is twice as long, but there's, I guess, twice as much field there now too in that small area of that bobbin. So, and I think it'll end up, the potential for RPMs is always the same, I think, but how you get there is what changes in this case. So I don't know. I don't know if that's true, but I think like with just the 18 gauge strand would get up a lot faster, but I don't think the amount. Okay. Yeah, the thicker wire handles a lot more current. But I've seen these things go really fast without drawing any current. So don't know. But this cap bank now, let's see how much juice it's got. It's all right. It's not too full. So I love that new rotor, man. How it spins, you can barely see it. Except for like a silver circle. Oh, you gotta be joking. My TV just pooped out. Oh man. I think somebody's doing that, and I don't think they're doing it intentionally, but it needs to stop happening. Oh. All right, again now I can't see what's going on. I have to come over here and read comments. I hope people don't get ticked off, but I think I'm going to carry the phone around with me, maybe to get some better angles and stuff. Well, I think the voltage is initial. I think together as wattage, the order of magnitude increases greatly. I do think that these motors do run on more voltage though. So I think I could be all right with like having a 30 gauge or a 28 gauge coil as a drive. Maybe not. I say 26. That's a 26 gauge drive coil right there. Crackhead's coffee table. My goodness. I don't know about all that, but we do. Yeah, the stimulation is high here at Papa Bale's Pulse Motor Mayhem. We're working with tiny coils, man. I mean, look at this. That's a drive coil and a trigger coil, all wrapped in one. It's so tiny compared to everything else I'm using. I mean, look at it, and it works like wonderfully. It's running off of this cap bank right now. I believe it's like 17 volt, 500,000 micro. So it's like 6 2.7 500s in series. Hello, Mike. What's up? What's up, bro? How you doing, dude? Been a while, Mike. Sweet, man. Been advancing my knowledge in certain areas. It's been fun. All right, but I mean, going at like 24 volts. All right, let's see. Oh, we're good, man. We're good. Jenny hasn't been living here for a while though, but she's planning on moving back in, I guess, and everything's planning on moving forward. Everybody's good, in good spirits and everything. This is copper infused PLA. This whole base here, and it spins on the shaft, so it'll spin like that. I was thinking about putting coils on that or putting the magnets on that and then spinning it and then having the rotor that's going to be resting on top of there spin the opposite direction. Just hooking up the output. All right, so this is a double SG running on 2 power supplies at 12 volts to charge 2 12-volt batteries, one on each coil. And I haven't even turned on the generator mode yet. Sorry. I'm just trying to. Should turn on the generator mode. Because it kind of slows down, but the wave changes. See, so you hear it, like it sounds like it's slowing down, and it is slowing down. It sounds like it's going to stop, but it never stops as long as you keep the power on. And it generates at like 50% more efficiently than it does the other way. Asymmetric geometry, 5 coils instead of 4. Oh, well, I do kind of, but I do it with 9. And I know 3 goes into 9, so it's not really true. But instead of doing 8, I do 9. But I get what you're saying, and that's exactly the effect I was going for. I don't know exactly what I was going to see, but that was what was going through my head. Like have the odd number, and not only odd number, but maybe prime number of you know, magnets or coils. This is a 9 magnet rotor right here. I mean, it's yeah, it's pretty good. And this is a 3 magnet rotor. It almost gets going on its own when the magnet's resting over the coil, but you're not talking about changing the rotor, though. You're talking about the stator, right, Society? I'm just trying to clarify what you're talking about. I get the 5 instead of 4. I get that, and what it could be used for. So just the coils is what you're talking about, right? Well, let me show you something. See that green thing underneath the aluminum sheet there? That's a 9 magnet or a 9 electromagnet motor. I got 7 coils on there right now. I'm missing 2. I don't know where they are, but hold on. Let me. I can't reach over there. My extension cord doesn't go that far. Shoot. But yeah, I'm all about that. I got a 13 magnet rotor. Well, I mean, I do it with the magnets and the rotors. I can only make so many coils, but I definitely keep that in mind. Um, is there any like specific dimensions for the coils, or should it just be all the same coils? Wow, that cat bank is still running pretty strong. There's the neosphere. I want to kind of run that one on this, but let's see. Yeah, I'm not going to be able to do that. Saying more the ultimate electric formula, not the unlimited or limited time. Yeah, it's a solid concept. But I'm still drawing power from the wall to make it work. All right. So I'm gonna put this back up in the thing, and I'm gonna play with this sphere for a minute. All right. Mm. It doesn't like this coil. Oh, and the yeah, no. Let's see about this one. See, I mean, some of them are more touchy than others. Yeah, that's awesome. Three pulse motors going at the same time. That's pretty cool. You know what would be really cool? I think that red one right here, this one right here is better, is the best one for this. So I want to hook this up probably in this circuit right here. Because this coil is lackluster. It's not that great. This coil is better. Boom. Love it. You know, for a while there, I didn't know if I'd ever have anything that would be able to make it work. And then, you know, K Energy circuit and all my coils work now. It's like, wow, what happened? What's the difference? And I'm working with it over here on this breadboard right here, trying to figure it out. All right, I'm going to change up the power supply here from the cap bank to this battery. You can kind of tell it must have been below 12 volts in the cap bank. Get that pickup coil out of the middle there. Now I can get this. Now I can. All right, so this is that 9-coil motor, and I was just debating on whether I should go 3 magnets or whether I should go 9 magnets. Well, I mean, you could use this. There's a Watch Citizens. I think something like that. And they have a kinetic watch where if you like rub it or touch it or anything, it'll conduct enough charge to run it. So if it's something like that, I can see it working. Definitely. Okay. But I'm like talking after whatever it is you're talking about, it's been sitting in a garage for 50 years and nobody's even looked at it for 50 years. Is it going to start up when they go to turn it on? And one of the ways that could happen is if you have that kinetic ability. If you touch it and it works, that's awesome. Um, yeah, man. If it's just like as in a smart goal, like as in the immediate time frame and anything that it concerns it, yeah, that's awesome, man. You can make it last that long. That's good. At least until you get bored of it anyway and trade it in for a new one, a better model. You know, is it really that important? In a capitalist society, I'd say that free energy is the, it's not really on the top of the priority list. But, for different parts of American society, I'd say it's awesome, dude. It's blows my freaking mind every time somebody shows me a multimeter that says something that it shouldn't. And nobody's going to stick around long enough to see a car go forever. But I'm pretty sure that we can go, I mean, at least there and back, coast to coast, right? We can do that. At least coast to coast, if not more. But yeah, man, so a lot of things can be proven with math. Lots of things. But, a lot of those things, not none of them, but a lot of those things never matter, really. And literally, in the literal sense of the word, matter. They don't matter. But, some of them do. And even if they're right and you prove them to be right, are you ever going to do that crap? Never. You will never do it. So it doesn't matter. What does matter is the important things. And if you can go coast to coast without charging, I'd say that's a win. And I apologize. I just got a glimpse of the chat message. My TV's acting up, so I can't see what you guys are doing, and I gotta have my hands here. All right, and I thought something like that might have happened. That's why I left the case open for my screwdriver. I feel like the trigger coil is plugged in backwards. And yeah, that's a thing, man. You can totally plug it in the wrong way. I mean, I guess there might be a way to wind it so that you can do it both ways, but not so far as I've done them. I just lost track of where this was. So I'm hoping that I'm getting it right. Gotcha. All right. Let's hope I got that right, because it sucks putting 32 gauge wire in those things. Oh. I don't know. Hmm. Oh. Ha. Power came out. Damn, man. Wow. All right. Must have just vibrated open. I might have to switch those back again. Mm. I don't know, man. It was working really good earlier, but it was probably hooked up right. I'm hoping that this is just hooked up wrong. And now that the power cord is plugged back in, see, all the swapping was probably unnecessary. Yeah, but doing it without this circuit would have taken so much more time. Wow, did I make all that up? I don't know. Let's see if it's working to begin with. No. So we'll put these in, and I'm going to swap. Man. Is that working? I think that's working. Maybe not. Maybe it is. I'm going to cut this other one off so that I can hear better. I don't think it's going, though. I really don't. Try and get that chirp. I don't know what else it could be. No, I know it's not that. If there was a transistor, we'd be getting amp spikes. And because I know it's not. And it'd be mass, magnet. It'd be a permanent magnet. We had a transistor problem. This is a little, I mean, beautiful and all, a little counterintuitive for me. What the hell? All right. Okay, but that's because I'm. All right, so we're going to use the 20 gauge strand. Fewer connections, the better. And then I'm going to get a reading on that 22 gauge strand as soon as we get this working. Mm. Mm. Man, I don't even know what else to do. It's, I mean, I was just using this one over there, so I know it should work on this. Okay. Nah, I'm good. I'm just. Man, these connections just aren't good. I don't know what I'm doing wrong here. No, something. I mean, I was just using it with that other coil. I don't know what's wrong. It's got to be the coil, right? Yeah. Unfortunately, I believe that is the case. So I got an idea. I know this is going to be weird. Probably should have done this a long time ago. I'll take this out. Yeah. And we'll put this one in. Mm-hmm. There you go. You know. This screw is either stripped, which is ridiculous. Yeah, it won't screw. I'm so just bewildered right now. Here we go. Think. Right. Happens pretty much every time I try and go live with it. It's like working wonderfully all day, and I'm like, all right, yeah, we're gonna show people that you've learned something or whatever we're gonna show you. And just no. It's somebody said no. I don't mind hearing no every once in a while. Okay, this is... All right. Now I am almost positive that it's not going to stay there. So I'm going to heat up the glue gun while I mess around with it, make sure it's working. Mm. I don't know. Something's not right. I'll fix it later. Just, I'm not doing it right now, obviously. Because there's only so many things you can do, really, before you just got to admit that something isn't right. Man, that sucks. I know what we can do. Haha. Take that and our needle ball. We'll take this off first. And then I got my pot in here, man. We're gonna work magic with this thing. All right. Hell yeah. Super cool, man. That was awesome. Had a levitating. I lifted off a couple inches off of there. That's neat. Oh yeah. I love my little coils. They're awesome. I don't know. There might be something wrong with it right now. I gotta check it out. And I don't know what it could be. Nothing looks fried. I mean, the light looks a little charred, but it's been used a lot. So, yeah. But when this one isn't working, I don't like that. I don't like that at all. Maybe I don't know. I'm gonna let it go for right now. But that sphere is. I love that sphere. Heck yeah, man. That's awesome. All right, this right here is it's supposed to be a counter-rotator or the beginning of one, but the hole in the center here wasn't straight. So when I put the rod in, it was crooked. Um, but you're supposed to spin it like so. It'll be battery operated. Everything will be all up in it. Maybe we'll put a little cap on there so it's more pointy. I mean, it is a little off balance, so it might not work at all, but or we will have to put it in like a pillow block bearing and then spin it like that. But that little rotor that I was just working with, this one goes with that. So you got something like this, and then you make a space large enough for one of these coils to go in there. Maybe 2 coils, but you're only going to need 1, I think. And then the other side's got your circuitry and your transistor and everything you're going to need. And the weight should balance out if you use a 9-volt battery. So you spin this way and that the other way. And then it should like take off, man. That would be sweet. It's all made of copper infused PLA. So that if that has any effect, which I don't know if it will, I don't know how conductive the copper infused PLA actually is. Yeah. Yeah, and that transistor on that one is ice cold. What's up, Wonder? Hi. Hi. So fast, so smooth. Yeah. Need a hand? Need a hand? All right. Let me show you what you almost had it. There you go. You can't get that off. Don't even try.
You put that one on there?
Yeah, that's what I'm doing. See, I got this ferrite disc over here that I was trying to use to generate eddy currents in my aluminum disc because they're the same size, right? Only this doesn't generate shit. Doesn't generate anything. 0.07 of a volt. Going really, really fast. But then again, I am just using this coil and that coil in series to pick up the eddy currents. So it's not like the best system. It's just a few of my radial coils. Hold on. I think that's right. Let's try it. All right, spin it. So easy. It's like, and that circuit is that easy, but I don't know what's going on with it right now.
It's so, I spin it so hard that the coil is moving.
Yeah, that's awesome.
How does it generate its white? Like, how does it work? Like, how does it make that go up? How does it make that go?
Well, you got the electricity, or the current coming in from the power source, whatever it is, ether, freaking a battery, freaking whatever your power source is. You get your power from your power source. It goes in to this little thing right here called a transistor. And then there's two wires in this coil, okay? One of the wires makes this thing work. The other wire takes the electricity and makes an electromagnetic field. So it turns it into a magnet. Make sense?
Yeah.
And that's what makes it move. One wire makes it.
But that was satisfying because that was cool.
And you can see that the thing is just on the very edge of the coil and it's working.
No, not that way. That's the other way.
So like, that's awesome, man. That is such a good coil in my mind. It's functioning so well. And I think it has to do with this circuit that I built. It's very functional. It doesn't have any but getting the second one to work's proven to be quite a challenge so far. I mean, I just started working with it. So we got 3 rotors that I use to generate eddy currents with. This is one. And when I put this on here, the very edge of the magnets are like in contact with the rotor. The very edge of the magnetic fields are in contact with the edge of the rotor. So you get about 1 volt of eddy current, 1 DC volt. I don't get any AC readings. I don't think my stuff is designed to read eddy currents. So, but it reads DC. And I am getting DC. All right. And then we got little devil over here, this little one. You naturally you put this on there like this, resting above a little bit. And then, they don't move very well with the aluminum.
It's a good spot.
Yeah. So you either have to put in a lot of power to get them to move, or you have to raise it up to be like a fair enough distance away. So it's just magnetic field. It's all right if it moves a little bit, but you're trying to get the disc to be stationary and have the magnet. Uh, do all the work. I'm just getting into it. I'm just starting to learn about are wanting to even learn about it. There you go. That's awesome. 12 volts.
Whoa, that's going fast.
Yeah, don't put your hand on that. And then I want to see how fast this one will go.
Oh,
This is the one I generated like 2.5 to 3 volts of eddy currents with, because you put it on there and you got like half of those magnets going in on your disc, about a half an inch. So I got about 3 volts of DC off of the aluminum rotor. It's a 1/4 inch of aluminum, so I'm thinking it's yoking pretty good. You know, it might be the magnets totally, but it's definitely a very low reading from the magnets, considering how strong they are. Start.
Nope.
Smart kid. Your fingers are really loose, like a noodle, a limp noodle.
Yeah, I got small fingers.
No, leave that there.
There's no.
That's not good. It feels like there might be glue in there.
Your face. Your face.
Neat. Cool.
Yeah, that's super close to that girl. That's super close. Alright, when this table shakes, you know it's going fast.
So cool. Such a little coil. I mean, it's less than 1,000 turns. It's like right around 1,000 turns.
Like 900. Oh, I have been better. Give me a lot. That's gonna be like a lot kind of slow, and you don't have the coil working because it's too big to spin for a long time. If it's small, you can learn to stride.
I'd say that's pretty good for the little coil. Thank you. Now I'm thinking one of these might be loose. That might be my problem. Yeah, you can open that.
Oh,
1K ohms.
1,000.
25 watt 1K pot. Super duper spectacular, man. All right. So I think what I'm going to do is I'm going to take these two 20 gauge splices and I'm going to put them in the trigger coil slots. Now I'm going to use clips. Might as well get the other two. It's funny to me. Well, it's not funny at all, really. This stuff can be working like all day. All day. Well, not all day. Just every time I turned it on is what I mean. All right, we're just gonna let them work till the battery dies. But I knew it was a bad, like, 32 gauge connection. Trigger coil. What a pain in the butt. Awesome, dude. It works. It works. I'm just glad, that works, because it was a good investment, and glad it's still with us. All right, so we'll flip the switch here. Now it's a dual SG generator circuit. See how much this little bad boy can generate. Holy smokes, man. So I turn on the generator circuit and instantaneous magnetic effect. At least my glue gun is ready. Wow, that. See, now I'm glad I hooked up those extensions. All right, we'll let that set for a minute. I'll set up some eddy current. I don't have maybe there's one lying around somewhere that I can use. So we get it so the disc will be elevated slightly. Just a little bit though. And with this one, it'll spin like effortlessly pretty much, but we don't want it to do that. We want it to not spin. So neat. I love my little coils. Heck yeah. Now we'll do little devil and big papa over here. That one was already on, so let's just do a little devil for a minute. So I'm going to try and assert some pressure on this and then bolt it in there. It still spins pretty good. That's maybe not good enough. There's a bearing in there so it'll fit around the pole tightly. Yeah, that's a little more taut. No, that's not good. Yeah, I don't know. Oh, I mean, before I use this, but I don't want to have this plate there anymore. I just want to put them directly, the coils directly onto the aluminum disc. Yeah, I don't have enough stuff, but I get about 2.5 volts from that. Using these coils, 26 and 32 gauge. So, I mean, if we up it to like a 42 gauge and you have it be either bifilar 42 or single file 42 gauge coil, we're gonna get like 5 volts at least of DC electricity that we can use. I don't even know if the AC electricity, because it didn't register at all when I looked for it, but the DC voltage did show up. So I'm just thinking that it's my meters that can't recognize eddy current. Because it's quite literally, it looked like the DC voltage was coming from nowhere. And I know that that's not right. Checked all my connections, so I know they were right. Just like I did here. I checked them all, and I checked them all again and again until it worked. So I know how to check it. Definitely all good there. It's right here. Yeah, I just did it earlier today. I have an idea. Maybe it will work. So I'm thinking, no, that's not going to work. Yeah, that's not going to work. I want to do something like that where where the shaft is like holding it in place, but I don't want it to be permanent, you know? I just want it to. Sucks when you can't think of that one thing you have lying around your house that could help you. So let's elevate the disc a little bit. All right, that looks to be about right. I mean, it's going to spin if you don't hold it, but see, that's generating eddy current just like that because the disc on top is going slower than the one on the bottom. Wow, that's a powerful little coil. I'm guessing it's the shape of it and how the hole is like really big in the middle, and then there's just a little bit of area for you to put wire around that. And that's only 20. I think it works best with 26 gauge because you can get, you know, the maximum amount of turns and uh, power, you know, so it's not as, it's the happy medium, I think. 26 for this coil size. I mean, this bobbin, you try and put a bunch of 20 in there, you're only going to get 200 turns. I'm gonna try and I need to see how much power I need to put in to make this spin with the disc that close without the disc counter spinning, or trying to sync with it. So in order to do that, start by turning it up to 15. So there's very heavy brake action going on right now. So we're at 19.6 volts. I'm using my personal contraption over here. Don't want to mess stuff up. That's going pretty good. Usually it doesn't go that fast or that well, like initially. Usually I got to start it up a few times. I mean, I don't have a coil right now to pick up the eddy currents, but I put them both on this black disc right here, or whatever I was using. Let me see if I can find a 32 gauge coil real quick. I'll be right back. Well, I got a lot of 26. I don't have much 32 just lying around. So All right, so we're getting like 0.02, 0.03, 0.04. Very low with the 26 gauge. Ah, but I'm going to make a 32 gauge straight up. Actually, I have one right here. It's my trigger coil for a counter rotator, but I'm not going to take that apart to get at that so I can prove that this thing is generating eddy current. I don't need to do that. Right. Now I do want to do something with this. And I think I'm going to work with this tonight maybe or tomorrow. And the one of my counter rotators I will dismantle for the coils. Should be pretty fun. Now if I put that thing on like a Lazy Susan, the wide Lazy Susan with the hollow center, hell yeah, man. Then I can put the rotor in the middle and that thing could spin like this and the rotor will spin like this. And then be a big old counter rotator right there. But I mean, just making that add stator thing so it can spin is going to be a whole marvel of ingenuity in and of itself. Sit down and you think about it. If something comes to mind. Huh. I need to see for sure. Oh, look at that. Now the disc is being hit from both sides because these are synced up. I want to see that. If that'll actually work. That's 25 volts. Oh, that would have been sweet. Just to sync it with magnetism and then have it be a hit from both sides of the disc. I don't know. Then there's no place to put the magnets though. So, I mean the coils. And I mean, like, Counter-rotator is a toy. It's not designed to you get readings from. You're, like, how many currents or how many, are you generating? Well, I don't know. I really don't care because that's not what I'm doing. Even if I'm generating a whole bunch, it's not really floating my boat. But here. I'm surprised my mic has held out so long. I don't even know how long I've actually been on, but it feels like I've been doing this for an hour or so. Okay, so what I want to do is I want to set up a maglev for this rotor. Let me see if there's any, like, okay, so this side sucks the rotor down. If we want more balance, we want this side to be facing up. I don't know what the effect of. Wait a minute. Turn it upside down like that. See if we can't have it repel itself. And maybe we stack two of these. But let's give this a shot. Wasn't as strong as I thought. Couldn't get a feel for it right there. I think this is, nope. I'm going to thrill myself when I get this done with one hand. All right, I know what I got to do now. Remove this one. Put this one right here. Boop, 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 boop. We're going to let that glue gun heat up a little bit. Get some water. Now that 9-coil green and gray build, I'm going to have 3 drives. Each will have 3 poles, I guess you call it. So 3 drives, 3 poles. That's 9 hits per rotation. And then, you know, I got this rotor over here, which can do an additional, it has a spots for 12. And it can, you know, 1 coil per magnet, or you can basically 3, 4, you know, I don't know what I'm saying. But, you know, I always like to try and match up at least the coils with the magnets, if not some sort of proportion or ratio. You know, like If it's going to be 120 magnets, then you should have like either 3 coils, your 1 coil, 3 coils, 6 coils. You can have as many coils as you want as long as they can trigger themselves, right? If not, you got to split the board up with trigger coil and drive coil. But I don't know. It's fun, man. Making a DC motor that moves pretty fast is it's fun, especially when you hit it and you get it right and everything's connected properly and it's working. Let me check the heat on this. Yeah, okay. I think we're good. Mm. Damn, that's way too long. We'll see if that took, but I mean, just all this stuff. Man. Hopefully it's centered. Put it like right in the, I knew that was going to happen. Yeah, it's not ideal. Cords are never long enough. You get enough room to walk around and get to every spot in your table where you need to be, and it's ideal that way. But then your plugs are on the walls, so you can see the problem. And say you don't have what it takes to go out and buy an extension cord every freaking time you need one. Just say, let's say money is a huge issue. Toilet paper comes first. How's everybody doing? Oh man, I gotta let that glue gun heat up a lot more than it did. As a matter of fact, I need to get probably another glue stick or two. See if I have any out here. Be right back. I honestly have never gotten a coil to start a motor. I've gotten a coil to make a motor move before I move it, but it never starts. It's just, and I know what you mean, just have it move it just enough to go past the trigger coil just one time. That's all it needs to do. Especially if it's a good circuit like this one. It only needs to pass, one magnet needs to pass one time for it to turn on. So if you can get it to do that, you can probably do it and get it started with just the one, without it needing to move it. Spin it with your hand. But you gotta realize, man, that some SGs are more sensitive than others. And it's just because it's not a replica. It's not, this is a replica, as far as I know. K Energy Store, SSG, generator combo. As far as I know, this is the way the circuit is, you know. And then you got what I'm doing over here, which is not the same thing. I don't believe that this will be able to ever start itself. Not the way I have it. No way. I love it, man. It's so neat. So the thicker gauge wire carries more current, but do you need more current? My answer to that question is no. You don't need current. You have to have a minimal amount of current for anything to work. But do you need it? Do you need it to be to have a really fat alleyway for it to go down? You need thick gauge to run a pulse motor. No. Will it give you more current? Yes. Will it generate more current? I'm not exactly sure how that works with SG. I know that you get pretty much what you put out, what you put in. That much is clear to me. But it's unique because it's like almost an entirely working on the capacitance and the of the motor, because you can run that 24 volts and you can hook up 3 motors to it via SG. You can hook up 3 of them in a row just off the one power supply, and they'll run equally as good. Well, not equally as good. It tapers off, but it tapers off slowly. Um, all right. I'm going to level this off while we're waiting for the glue gun to heat up. Glue gun's going to heat up, and then I'm going to attach this disc, this toroid, to the green disc. We're going to get ready to hook up the three phase. Maybe it's phases. I don't know if it's phases. I think in order to have a true 3-phase motor, you got to have just 2 poles, 1 magnet on the shaft in the middle, just one big one. And then you have your coil set up, so every time that the north and south alternate, or you could have 3, 3 would be cool, but if you can do it with 1, why wouldn't you do that? because you don't do it with just one man. You don't do a 3-phase motor like that. I don't really know how you do it, but I know that it's like a song, and you sing it, and you sing it with your friends, and then you sing the first verse, and then when you start the second verse, your friend starts the first verse, and then when he's done with the first verse, your other friend starts the first verse, and by the time you're done the third verse, your third friend is on the first verse. You know what I'm saying? And it's like merrily, 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 and it's like that. That's a 3-phase motor. And if you can't see that, I don't know, man. Maybe I know it's nothing that I did. I mean, I'm all for giving credit to where credit's due. All right. Oh, it looks halfway decent. No, nope. Man, I'm so irritated with that. I don't have my, even with those things, it's a shot in the dark. So it's all right. It's not dead center. It's going to shake a bunch, I think. It's really close. No, that seems farther away. I don't know, it might work. If not, I'll have to change it. Let's bring it in. Now, it appears that the maglev is a little low. Now, I got something for that. Be right back. Now, that might be too much, but we'll see. Perfect. It's almost like they were made for each other with the color and everything, but they're totally not. So I need 2 coils. All right, so it looks like these are 22 gauge coils over there, and the rest of them are 26 and 32. And there's 2 missing, and I think those were the 22 gauge as well. So I wish I could find those. This is going to be fun, guys. This is going to be great, especially if it all works out the way it's supposed to. So I'm thinking that I'm just going to substitute. I'm going to make them all 26 and then get rid of this 22 gauge one. And then I can substitute with these. Awesome. That's going to be awesome. And then I don't have to take apart my counter-rotator. And we get to see this be completed. This is from a while ago, actually. And it's conceptual, so I don't know exactly if it'll run like where it is or if it needs to be adjusted, made closer. I don't know yet. But that's the basic idea right there. You know, let me twist this. And then see, that looks a little far away. Just need a transistor for each coil, really. That's awesome. That'll work. Woo! That's just one coil. All right. That's good. I think that's awesome, at least for a day's work. All right. Well, thank you very much, ladies and gentlemen. Peace out. Have a wonderful night. Please subscribe, like, hit the notification bell, and have a great day. I'll check you later.